Okay, sectors of circles is something I wanted to talk about out of trig. So here we have our little orange circle here, and here's this sector that we're interested in. What I want to know is a couple of things. I want to figure out, or your professor is going to want you to figure out, how long is this arc length right here? Yeah? And the other question that he or she might want to know is, what's the area? What's the area? What's the area in here? So we're going to come up with some quick techniques of how to answer these two questions. They're really easy. It takes a little bit of memorization. And then in the second video, we're going to apply those things. So here we go. All right, here we go. Here's the first thing. In trig, we want to deal as much as possible in radians, but given the fact that we may have to use degrees, we'll start with degrees. And we'll start with a solid line. So starting with degrees, looks something like this. In degrees, S, our arc length, S, is equal to theta over 360 times 2 pi r. This makes perfect sense. Don't get rattled about this. This makes perfect sense. This gives you the percentage, doesn't it? And this gives you of the total. So here's the arc length. The area, if we were using degrees, the area, so the shaded area in here, would be equal to, again, theta, our angle, our central measure, over 360 times pi r squared. Can't let this rattle us either, because look, this gives us the percent right here, right? This is the percent of the circle we get, and this is total area of our circle, so that makes really good sense to me. Here's what we're more likely to see. So here's what we're more likely to see in trig, especially, is we're going to see this in radians. So in radians, it's a little bit different and frankly easier. In radians, we're going to get our arc length S is just going to be the radius times theta. That's a damn sight easier, isn't it? And our area K, remember, area K is equal to area, right? S is equal to the arc length. The arc length. How far is it from here to here? All right, but we're talking about area now, and the area will be the same, will not be the same thing, will be 1/2 r squared theta. So some of this is memorization. Actually, everything we've done so far is memorization, but the application of this is really, really cool. So this is, sometimes we put these two together. Let's call this formula A, and let's call this formula B. So if we put formula A and B together, we'd say this. We'd say, well, K, the area, is equal to 1/2 radius squared theta, which is the same as 1/2, isn't it? R times theta. Now, this is an R here. Look, if we did R times R, we get our R squared back, and this theta is that theta. We haven't changed a thing, except for the fact, check this out for just a second, please, is we can do this. We can look at this. Whoops. We can look at this piece right here. Look at this piece right here, and right, we say that S is equal to R times theta. But look, here's that R times theta here. So we can use this S here, as a replacement value for that, can't we? Which simplifies out. This is really, really cool. This is used a lot. So finally we get to K. The area is equal to 1/2 RS. And in the next video, I'm going to show you how this is applied. It is so good and so easy that you'll be looking forward to these questions on your exam. So I hope that was helpful, you guys. If you haven't already subscribed, please subscribe. Share my videos with friends, and your comments, as you know, are always welcome, and I try to respond to everybody who writes. So thanks for all the support.